Here we go. Welcome back, nerds. Today we are doing some practice. Cool. So you guys elected this one. I'm stuck already. I have no idea what to do. I'm not going to call numbers, but here's the rule. Same person can't answer twice. I'm just going to let people volunteer. We'll just hang out awkwardly. So as much as you guys want to get through, you just got to make sure that the conversation keeps going. I'm stuck. Ideas. Hit it.
I mean, it might be stupid, but I guess if we use I chose sign effect.
Okay, we could try use substitution. Reasonable. Anybody have a different thought? My first thought is that this is cotangent, and then I'm thinking to myself, do I know the integral of cotangent off the top of my head? Well, the derivative of cotangent is nice. Does it have a nice antiderivative? I don't recall a nice one, not off the top of my head. Doesn't mean it doesn't exist. Like, my memory's not great either. So cotangent x cosecant x is the derivative of cosecant, but we don't have a cotangent cosecant. We just have the cotangent. So I like JJ's idea if we just are looking for something to try. What would you pick, JJ? I don't know why the emphasis is weird there. Sorry.
I think sign effect.
That's a choice. I think it's the same choice that I would make, just for the record. Okay. Now, if we're wrong, is there any huge issue with that, other than we just have to try something else? No, I don't think so. So anybody but JJ, now that I have you, what would you do? That might be a hint, unintentionally. Yeah, what would you do? All right. What's the derivative of sine? Cosine. Cosine x dx. Now, this is where normally our next step is solving for dx, right? This doesn't happen all the time, but it does save one line of writing if you'd like. Do I have a cosine x dx already written here? So I can just replace all of this with du. Now, if we solve for dx and we said that, oh yeah, it's du over cosine, we're going to get the same thing, but we can save a line of thought here. Okay, do we want to change our bounds, or do we want to change it back to sine x at the end? Because we're about to change a function in x to a function in u, right? Like that's the whole u substitution. These bounds are in x. We can either keep them in x and then just do the integral and go back to x, or we can just change it all to u and work with u. What option should we go with, do you think? Yes, 2 is what I was hoping for there, just so you know. But how do I change these bounds to u then? U of what is one of them? Pi halves, and this is the upper one. U of pi halves. Now, you guys have the unit circle maybe kind of memorized. Can you guys point to pi halves on the count of 3? Oh, got you guys good. 1, 2, 3, go. Okay, here I am. What's the ordered pair on my unit circle? And which one is the sign? Sorry. Why? So what's u of pi halves? 1. What's u? Point to pi fourths. Ooh, are you sure, Sean? Here's 0 to pi, right? So you guys told me correctly. Here's 0, pi halves. Half of that, pi fourths. What's sine of pi fourths? Root 2 over 2. Love it. Okay, we have done all the lifting here. Riley, we're doing one problem, handing it in, taking the test today is what everybody decided. Doing one problem here as review, handing in our practice test, and taking the test. I have a feeling like you know I'm lying to you. You didn't seem, or not, maybe not, okay. You didn't seem very bothered. Okay, so let's continue. What's the integral? From where to where? To 1 of what? Is it, it's 1 over u, right? It's because it's 1 over cosine is all that's left. And instead of 1 over u, is there anything else I could write instead? You're yes, 100%. I would just do this here. But you're right, it could be the other way. I would not do it the other way Because u to the negative 1, if I write it like that, you're going to try to use the power rule, and you're going to try to divide by 0, and you're going to destroy the universe. Instead, we could all recognize that this is nice. What's the integral of 1 over u? It's the natural log of u. And then we just do these bars, root 2 over 2 to 1. And then how do we apply this fundamental theorem of calculus? Good. So natural log of 1. And since these are both positive, I'm not going to use absolute values because they're already positive. So this becomes a natural log of 1 minus, and there's a bunch of different ways that we could write this. Whoa, not equals. Minus, sorry, eventually. The natural log of root 2 over 2. Okay, well, what do you want to do? What's the natural log of 1? It's not 1. Why is it? Can you explain why it's 0, Abigail? Good. Remember, this is log base e, and I'm not going to write out all the log stuff, but when you're trying to think about what these are, e to what power question mark equals the argument. That's what this is, and it has to be 0. Okay, this one does not look like any of our answers. Does it mean we're wrong? No, but it does mean something wonky has to happen. We're going to try to deal with this. Root 2 over 2 shows up on the unit circle because it's nice. Could I unrationalize this for just a second? How? Like, it's weird right now because right now my answer says 0 minus the natural log of root 2 over 2. Is this one of these answers, do you think? I bet it is. Which one? Why B? So, careful. Do we all agree? Like, talk with your neighbors. There's some crazy stuff, not really crazy, but there's some log properties that we're not using right now. See if we can find one of these answers here. Just so you can see it. And, sorry, I guess there were 5 there. I didn't mean to hide them. That was not intentional. But we still don't have our answer. But we will. Love what you're thinking. Sorry to comment. I can just happen to hear your thoughts. Here's the only downfall of this. So what I did here, I had to make this. I went through like 30 years of AP tests, and all I did was copied and pasted, like I snip tooled, and I found only the problems that had derivative or integrals, and like I separated them into all these categories. So I cannot tell you if this was a calculator or non-calculator problem. If it is a calculator problem, is this one of those? Okay, not nice. Lesson 1, sorry. Grab your calculator real quick. Let's just check. I assume that this is a non-calculator problem, but we'll dig into the log stuff here. So while you're doing that, I'm going to write a couple comments. I just want you to evaluate this, natural log of root 2 over 2, and we'll see if it's any of these. So the pi force is a good idea, but root 2 over 2, I would be very careful because unless we have the sine or the cosine of that, we're not going to jump to the unit circle. But I like that thought. I'm going to do something else here. I'm going to make a little comment here. That's what I have. That's my first thought. I didn't touch a calculator yet. This note up here. If we were to rationalize this, we get this. Why would I care that this is the same thing as saying negative the natural log of 1 over root 2? Oh, there's division rules. So if that was 0 minus this, let's just go one step further. What do you mean division rules for logs? I see my arguments are dividing. That means the logs must have done what? Subtract. So do you agree that this would have been 0 minus the natural log? I'm going to put brackets here because we're subtracting all of it, right? Of 1 minus the natural log of root 2. And it's super important here. If you have no idea what I just did, please speak up now. I'm the 2?
Yeah.
Which 2? This one?
Yeah, in the brackets.
So when we're doing this, here's a property that I'm using. I know that if you take the natural log of a, or any log really, but a over b, this can be expanded as a natural log of a minus a natural log of b. That's what I'm using here. And this one, if you have to de or unrationalize, is a weird idea. But if this isn't clear in how I got there, I happen to just know that this is what it shows up as. If I didn't want this radical to be up here, we'll play the algebra game real quick. Could I multiply this by 1 over root 2 right here? Kind of. Like I'm cheating right now, but there's one more thing that I could do and I wouldn't be cheating. If I do this to the bottom as well, I have a 1 up top and I have a 2 over root 2. So it looks like 1 over, like we can clean this up. It's 1 over 2 root 2 is what winds up happening, I believe. So I might be a little bit off, but let's check. So up here it's just 1 over 2 over root 2. And that's root 2 over 2. So let's check. Am I getting goofed up here? Am I getting goofed up here? Because that's just going to give me root 2 over 2 again, right? Times. This is, I don't know why I'm hiccuping here in my brain right now. If I have, we'll just verify. 1 over root 2. How would I rationalize?
Oh.
Yay!
You act like my computer doesn't have